A cargo ship slides above the highway. Its hull clears the rooftops, and a mother pushing a stroller below has to yield. Legally, the ship has right-of-way. The ocean sits 7 meters above that street. One wall holds it back. 26% of this country should be underwater. Right now. 17 million people live on the dry side. That road sat 3 meters under the North Sea in 1953, when a storm walked in while the villages slept. January 31st, 1953. A storm forms south of Iceland and aims directly at the Dutch coast. The North Sea is a funnel. Every Atlantic storm compresses into the shallow channel between Britain and the continent, and the water stacks higher as the seabed rises. This storm hits at high tide when the sea is already swollen, and the combination drives a surge straight into the southwestern delta with nothing to slow it down. At 4 in the morning, the dikes broke. The villages were asleep. Water poured through gaps that widened faster than anyone could reach them, swallowing farmland and roads in the dark. By dawn, 150,000 hectares had vanished under the North Sea. One village lost 305 people before sunrise. Across the delta, 1,836 never woke up. The sea moved faster than every warning system, every telephone chain, every church bell that tried to sound the alarm. Entire communities drowned in their beds without knowing the dikes had failed. One mayor saw his dike crumbling and made a decision that had no precedent. He ordered a ship captain to ram his vessel directly into the breach, plug the gap with the hull itself. The captain drove the ship into the collapsing wall of earth and held the sea back long enough to save an estimated 3 million people behind it. A man destroyed one thing to keep everything else from disappearing. The flood receded. The damage didn't. The southwestern delta lay open to the ocean, and the dikes that had held for generations had proven they could fail in a single night. 17 days later, the Dutch government issued 2 words, "Never again," and commissioned a plan so radical that the engineer who had spent 20 years warning them about exactly this disaster had already died before anyone listened. The Delta Plan demanded something no country had attempted: shorten the entire Dutch coastline by 700 kilometers using structures that had never been built. The first step alone sounded like madness. One straight dam, 32 kilometers long, thrown across the open Zuiderzee. The violent North Sea on one side, a tame freshwater lake on the other. Cornelius Lely had proposed exactly this decades earlier. They called him insane. He died before a single shovel broke ground, but his drawings survived him, and in 1927 the government finally committed to building what he'd imagined. 10,000 workers spread across 4 simultaneous construction sites, building not from the shore outward, but from the middle of the sea in both directions. 27 dredging ships vacuumed the ocean floor and piled it upward. 36 million cubic meters of sand and clay heaped into a wall, while the North Sea tried to wash every load away. The sea sent quieter weapons too. Woven willow mats had to be sunk to the seafloor first, because without them, the clay simply drifted into nothing. Those mats held until shipworm ate the wooden foundations hollow from the inside. The base rotted in silence. Engineers tore it out in winter, in open water, and replaced the wood with basite, it mineral that laughs at salt water. They stacked basalt by hand on the seaward face, the hardest volcanic rock they could find, and dared the ocean to move it. Then came the final gap. 50 meters of open water left to close, tide ripping through at 5 knots, the current fighting every barge that tried to hold position. The engineers waited for slack water, the single moment between tides when the sea pauses and the current drops to nearly zero. That window lasted minutes. The barges dumped. The gap shrank. 30 meters. 10. One afternoon, an entire inland sea surrendered. One flag planted on the crest. The dam locked the North Sea out. but the engineers stared at the freshwater lake behind it and wanted something more. They wanted the floor underneath it. The entire province of Flevoland was open water in 1940. By 1967, the Dutch had pulled it from the lakebed, the largest land reclamation in history, built by trapping patches of lake inside ring dikes and pumping them dry. The pumps ran day and night. Centimeter by centimeter, the water dropped, and a seabed unseen for 10,000 years began to surface. It looked like Mars, gray, cracked, utterly lifeless. Then the wind carried reed seeds onto the exposed mud without being asked. The reeds took hold, their roots threading through the wet clay, pulling moisture out of the soil and drying it from within. The engineers had planned for exactly this. They had engineered a collaboration with weather itself, letting nature do work that machines couldn't. But the land fought back the moment it dried. Draining compacts clay, and the new soil began sinking under its own weight. The Dutch had engineered their own slow-motion crisis. Drain too much and the ground collapses. Drain too little and the province stays swamp. The answer was controlled compaction. Keep enough water in the soil to hold its structure, remove just enough to make it farmable. Every ditch calibrated, every water table monitored, the margin between solid ground and subsidence measured in centimeters. They laid roads before houses existed, surveyed farms before a single resident arrived, planned an entire city on paper while the soil was still drying, then built it exactly as drawn. 3 pumping stations have been running continuously since 1942, never stopping, not once. If they shut down, Flevoland floods. An entire province exists only because machines hold it above the waterline the way lungs hold air. One pause, and it drowns. Everything the Dutch learned draining a quiet lake, they now had to apply to the open delta, where the sea pushes back through every inlet twice a day. Solid dams sealed every inlet in the delta except one. A 9-kilometer gap in the eastern Scheldt remained open because closing it would kill everything inside, the mussel farms, the tidal ecosystems, the fishing communities whose livelihoods depended on the sea flowing in and out twice a day. Engineers had already spent 10 years building a solid dam. Then biologists and fishermen forced a reversal. Scrap it, start over. $2.4 billion and a decade of work abandoned because the estuary refused to be treated like a lake. The new design asked for something that had never existed. 62 steel gates, each 42 meters wide, hanging between 65 concrete piers stretched across 9 kilometers of open sea. Open in calm weather to let the tides pass. Closed in storms to seal the estuary shut. A wall that appears only when the ocean attacks. Building it started with building an island. The engineers cast an artificial construction platform in the middle of the estuary from nothing. A workspace in a tidal current where no land had ever been. 1 pier per month cast on that island. Gate guide slots machined to millimeter accuracy in concrete while the sea pulled at every form. 5 years of casting before a single gate could hang. The seabed had to be prepared first. Concrete mattresses weighing 5,500 tons each were lowered 30 meters to the bottom and placed within 20 centimeters of their target position. 2 ships were built exclusively for this project, each capable of lifting 20,000 tons. They were never used again. Then a void appeared under 1 pier foundation, 15 meters across, a pocket of nothing where solid ground was supposed to be. One miscalculation nearly swallowed the entire barrier. Engineers injected grout through pipes until sensors confirmed contact. The pier descended. The crisis dissolved into concrete. Now the gates. Each one weighed 480 tons. Each had to be threaded into its concrete guides from a floating crane with 50 millimeters of clearance on each side. 1 motor, 1 spindle, no external power cables. Every gate entirely self-contained, because anything that depends on a shared system fails when the shared system fails. October 4th, 1986. Queen Beatrix gave the command. All 62 gates dropped at once. 9 kilometers of open estuary sealed in 75 minutes. The storm surge that followed hit concrete and steel instead of sleeping towns. The eastern Scheldt barrier saved the delta, but Rotterdam, Europe's busiest port, couldn't afford a wall that stays closed, because closing the river kills the economy within hours. Rotterdam's port moves more cargo than any port in Europe. A permanent barrier across the river would strangle the economy in hours, so the engineers had 6 years to design a machine that could seal the waterway in a storm and vanish completely when the storm passed. What they built defies intuition. 2 hollow steel arms, each 237 meters long, each heavier than the Eiffel Tower, sitting inside dry docks on opposite banks of the river. When a storm comes, the dock gates open, the river floods in, and 6,800 tons of steel begin to float. The arms swing outward across 180 meters of open water, meet in the middle, flood their own ballast tanks, and sink to the riverbed. Port sealed. The construction alone required arrogance on an engineering scale. Workers excavated 2 massive concrete pits on opposite banks of the busiest shipping lane in Europe. They poured the foundation while cargo ships sailed directly overhead, commerce and construction occupying the same water. The arms pivot on the world's largest ball joints, 10 meters across, 680 tons of steel each, manufactured in the Czech Republic and fitted once. One attempt. Each joint lets a 6,800-ton arm swing with complete freedom, and if the fit is wrong, the barrier doesn't exist. The first time the gate floated, it rode 340 millimeters off level across its 210-meter length. That tilt would have been catastrophic in deployment, an arm that heavy listing in a current could tear itself from its joint. 26 internal ballast compartments, each individually adjustable, let engineers redistribute water until the trim reached 15 millimeters across the full span. They taught 6,800 tons of steel to float level. No human decides when the barrier closes. A computer system called BOS monitors water levels, wind speed, and tidal predictions around the clock. BOS decides. BOS commands. When the river climbs 3 meters above normal, the arms start swinging. November 2007, BOS triggered for the first time. The arms met. Rotterdam stayed dry. 6 hours later, the gates opened and the port resumed as if nothing had happened. Steel saved Rotterdam and the Delta, but dozens of smaller towns along narrow waterways couldn't support the weight of steel, couldn't afford the cost, and needed a defense that no one could see until the moment it mattered. 3 rubber Kevlar bladders lie flat on the riverbed, invisible. No infrastructure visible from above. No cranes, no gates, no steel. 110,000 people live behind this waterway, and their only protection is 2 centimeters of reinforced rubber tested to destruction before installation. When an alarm sounds, pumps force air into the bladders. 30 minutes later, a 10-meter wall stands where there was nothing. The pumps sit inside armored housings that look like armadillos, because that's exactly what they are, shells protecting the organs that keep the wall alive. A storm hit at 9.1 meters. The barrier reached 8.2 meters, 900 millimeters between protection and catastrophe. Redundant valves, secondary air supply, and real-time sensors were added immediately. That margin never appears again. Then the Dutch stopped only defending and started recruiting the enemy. The sand motor, 21.5 million cubic meters of sand dumped in a single mass on the coastline. Engineers walked away and let the sea do the rest. Waves have redistributed millions of tons for free every day since 2011, carrying sand exactly where the coast needs reinforcement. The ocean builds the beach now. Farther inland, The Room for the River program carved a 9-kilometer channel through farmland to give floodwater somewhere to go besides the city. 27 centimeters. That's how much one new channel drops the flood peak. 27 centimeters saves cities. 90 years of engineering, each barrier teaching the next, each failure sharpening the design. And in January 2023, every single one of them closed at the same time. Storm Peter Boz struck January 2023. The Maeslandkering sealed for only the second time ever. Every barrier closed at once, 1 century of engineering coordinated through a single command. 0 flood deaths since 1953. Not because storms stopped. Because the Dutch built something between themselves and the ocean and never stopped rebuilding it. The water is always there, always waiting. Next, a canal where ships climb 26 stories inside a concrete tube with less than a meter to spare.